And good morning, everyone. Welcome to another DigitalOcean Tech Talk. It's been a while for me, at least. I haven't been around since December, but we're finally back in the roll of things here for 2022. So, hey, Oleg, good to see you. We're going to go ahead and give it a couple minutes for people to drop in. We'll give it like 2 minutes, not going to wait too long. But it's good to see everyone. Where's everyone coming in from this morning? I know it's been a minute since I've personally done a tech talk, but it's good to be back. So, how's everyone doing? It's cold here this morning. It's like in the low 30s. Not enjoying that, but cool. Paul's coming here from Alberta. Good to see you, Paul. Sparks coming in from Belgium. Nidix coming in from Cornwall in the UK. Yes, it is chilly here today. So, cool. Mike's here to see what he can do with Terraform as a network engineer. There's some interesting stuff you can do with Terraform as a network engineer for sure. Rabiria from Ethiopia. Juliet's coming from Joshua Tree. Nice. Lloyd from Southern Wales. Good morning, Jacob. Phelim from Vienna. I did a study abroad in Vienna for a summer. Loved it. Absolutely loved being in Vienna. Mike from Pittsburgh. Iran from Israel. Kevin coming in from the Philippines. Nerdmore from Fabiano, Brazil. One of our LinkedIn users coming in from Toronto. I love how LinkedIn user just says LinkedIn user. Such a great integration. So nice. If only it was 2022 and we had software. We have Eduardo from Portugal. We have Hansal from Toronto. Alex from Denmark. Oh, they're all coming in. Great to see you all. I'm just going to click through them. Good morning, everyone. Good morning, Samantha. Good to see you. It's been a minute. Alejandro, Elliot from Guatemala. And hello, good morning. Okay, it's been 2 minutes. We're going to go ahead and get started. So today is a really fun day. We're going to talk about Terraform. This is one of my favorite topics to talk about. This is very likely going to be the first in a multi-part Tech Talk series that I'm going to do about just Terraform in general. You know, I've always done beginner Terraform talks, but I definitely want to do some advanced Terraform talks. So keep your eyes on that in the future, because I definitely may be doing some of those in the future. So let's go ahead and just talk about Terraform here for a second. So Terraform is a really, really fun tool. And basically it's an infrastructure as code tool. So what is infrastructure as code? Well, infrastructure as code is when you define the infrastructure that you have for your application. You know, say you're running a small little, e-commerce site, you have a database, you have a couple droplets. Terraform is the thing that would provision these databases, droplets, perhaps put them in a VPC, put them behind a load balancer. You could configure firewall rules for them. And basically the entire point of this is to allow you to codify your infrastructure. A big problem that happens in DevOps SRE space without automation is what's known as infrastructure drift, which is, you stand something up, okay, I stood up this server, I had it running for 2 years. How did I stand it up 2 years ago? I have no idea how I did that. It's time to upgrade from, like, say, Ubuntu 2004 to Ubuntu 2204, which should be coming out here in about a month. And like, how did I do this? How did I do any of this stuff? And that kind of knowledge can get lost. Or if, the person that stood it up leaves. So by defining your infrastructure as executable stateful code, it allows you to, have more redundancy, make sure that you can rebuild everything you need to build in case there's a cataclysmic event. Data centers do go offline. That is a thing. If you want to expand, it makes it a lot easier. There's a lot of really cool pieces to it. And I'm going to go ahead and answer the question that I know is on someone's mind that is always asked, and I'll probably answer it at least 3 times in this tech talk. Well, what about Ansible? What about Chef or Puppet or SaltStack? What about configuration management? It's a great question. They're not the same thing. So configuration management tools are really useful for setting up the infrastructure once it's up. So configuration management doesn't typically focus on in provisioning cloud servers. It focuses on making sure the right packages are installed, making sure the directories are set up, making sure the users that are there. This is stuff that you want to do that's config based. And you want to be able to run it multiple times. When you run Terraform and you create, say, a droplet, if you change anything in that, it's going to destroy that old droplet and create a new one. We may not want that. Maybe I just want to update a file. That's where config management comes in. Infrastructure as code and configuration, configuration management are not, they're not rivals. Okay, they're teammates. They're on the same team. I use Terraform and infrastructure as code to provision my hardware, and then I use Ansible or something like that to configure the hardware, and boom, we're ready to go. Now the question is, can I use one or the other? Like, yes, in theory I can use Terraform, I can use Cloud Init and submit all of these things via Cloud Init and a bash script. Okay, could I technically also do provisioning with Ansible? Yes, but the thing is, these tools are not, it's not what they're best at. Use a tool for what it's best at. Like, even in the Terraform docs, they will tell you is not a good idea to use it to configure. And there's a great answer right here. Terraform with Ansible as the provisioner. Exactly. And I think Terraform has provisioners built in. I know Packer does. It's a great way to do it. So just remember that these two are not rivals. These two are teammates. Like, this is like, if I had good sports metaphors, I would make a sports metaphor here, but I'm not a sports person. But these are like, if you can think of a dynamic duo in the sports field, or like, anything where it's just these two people that are just doing the greatest. That's what Terraform and configuration management are for, or infrastructure as code and configuration management. There are other infrastructure as code tools. So that being said, if you have any questions about it, you go to terraform.io. You can download the CLI. It's an open source product made by HashiCorp. Absolutely fantastic tool. And now let's just go ahead and get into it. So what I will do is I'll drop this in the comments, and we'll make sure we drop it a couple of times. And a half-hour workshop that I do with this. So we're going to get through with as much of it as we can. And what we don't get through, we'll come back and we'll do another tech talk in about a month on it. So the first thing that you have to realize about Terraform is it's a pluginable architecture. So Terraform itself doesn't really, like, by itself, doesn't really do a lot. Terraform is really a managed state machine that calls APIs. So what we have to do is we have to provision we have to tell Terraform, hey, I want to use DigitalOcean. And that's basically what happens. Anything that has a sort of stateful API can be used with Terraform. And I've seen some really interesting things. I saw someone write a Google Calendar Terraform plugin. I don't recommend that. That seems a bit excessive, but it is really cool. So what we have to do is we have to basically set up our providers. So in our Terraform main.tf, we basically say DigitalOcean. We're setting that up as our provider. We're going to say the source is equal to DigitalOcean/DigitalOcean. When you want to find these yourself, Terraform providers. You literally could just come here to the providers. So they have a registry, and they'll tell you how to use everything. So like AWS, Azure, Google Cloud, Alibaba, Kubernetes you can use. You can use it to provision Console, Nomad. There are a lot of different providers. And if we basically, there's a search. Yeah, search right here. We'll say DigitalOcean. So this is the DigitalOcean provider. It has the little Sammy Shark. It's a verified provider. It's provided by us. And this will tell you how to use it. So they've changed their website since the documentation. Here we are. So this just tells you how to use the documentation, or how to use the Terraform provider. So, and also if at any point you have any questions, please feel free to ask me. So what we really could do with this is we could just copy and paste this. So like, as all good programmers do, don't rewrite stuff that other people have written for you. It does mess up my spacing, but I'll get over it. So we provide the Terraform with the required provider, and we say we're getting it from DigitalOcean. DigitalOcean maintains this provider. So it is something that is, maintained by us. It's usually pretty well up to date. I know the team that maintains it, very good team. The version, I don't really recognize this kind of tilde squiggly syntax. I usually don't. This basically, I think, is saying use anything greater than 2.0. Usually I don't even put that. I just grab the latest, but you probably should stick to a version if you're anticipating a lot of changes. Then we have right here this variable do token. And what this does is this is basically defining a variable. So Terraform, runs on what's known as the HashiCorp configuration language, or HCL, and it's basically its own domain specific language for maintaining things. So we create a variable here, and this is basically saying we want a variable. This is telling Terraform when we run it to expect this variable, either to find it in a variable file, to ask us for it, or to look for it in environment variables. So the Terraform provider will not run if we do not provide this. And then by saying provider DigitalOcean token, there are certain variables you have to pass in to your Terraform provider, as you can see here. Some of these providers require a lot more. Like, say, if we were to go look at, like, say, the AWS provider, you can say region US East 1. You can put your tokens in here. There's a lot of different things that you can put in this section, and that is in the provision or documentation. For DigitalOcean, though, I've actually never seen anything in here used other than the DigitalOcean token. So basically, we have to generate an API token and provide it to the Terraform provider. So this is just all getting it set up. Now, if I were to go to my command line, and the first thing I have to do is I have my main file, and I have, cat main, and I have Terraform installed. Terraform is really interesting. It's basically just a single binary. So to install it, you could probably just download the file from the website, or some operating systems will have a package manager that will have it. But if you want the latest and greatest, it's always best just to download it directly from the website. So the first thing we have to do is we have to run a Terraform init. Now, what the Terraform init does is it goes and looks and sees all the backends that we've said and all the providers. So we've said, hey, we want the DigitalOcean provider. Terraform knows where these providers are at. So it basically does a version match, and it grabs the latest, latest 2.x version is what Guy says. So yeah, the latest 2.x version, which is pretty cool. So 2.18 is the latest one, and then it basically downloads it into this .terraform file and directory. Sorry, it downloads the provider and all of the code. So basically, it's a giant pluginable architecture that we can do with that. And now, if we were to run something like Terraform plan, let's say our infrastructure is up to date, there have been no changes. That basically means that we haven't done anything here. There's nothing to change. So there's going to be 4 commands that we're going to go in depth today, which is Terraform init, which is we just done. It's the one you use it once at the very beginning. Plan, apply, and delete are the 3 that we're going to use repeatedly. Plan plans it out, shows me what will change. Apply applies the changes, and delete deletes it. So because we have this, let's go ahead and talk about how to use Terraform now. So there's 2 different types of resources, and we'll just say, where is the documentation for DigitalOcean? They've changed their doc since the last time I've used this, so this is interesting. So there's 2 different types of things, of interactions with the API, with your provider, that you can do. They're called resources and data sources. Data sources are basically a read-only API. This is the ability for me to look at my resources and get information back on them. No changes can be made about this. So if I want to know what the IP address of a specific server is, I can use a data source to get its IP address. Resources, on the other hand, are how we actually create something. Now, as you'll see, there usually is a large amount of overlap. We can both look at our certificates and create certificates. So these do look very similar. There are a couple things, though, that are not. For example, we really can't manage our DigitalOcean account via the Terraform provider, but we can access some information from it. So let's go ahead and do that. Let's use this read-only thing to set up our API key. Oops, sorry. And to ensure that we are ready to go, and reading like ourselves. This will allow us, we'll read something out of the Terraform provider to ensure that we're just ready. This is basically the hello world of Terraform. Can we read something from a data source? So what we're going to do now is we're going to go to our DigitalOcean account, and you're going to just create a API key. Interesting. So what we're going to do now is we're going to just generate a new token, we're going to say Terraform. And we are going to give it write permissions, because if we don't give it write permissions, it will not have the ability to, I like that it has expiring. It will not have the ability to create any resources for us, and then we'll run into that. So what I'm going to do is I'm going to generate this over here and copy it, because I don't want anyone to see the key. And now one of the cool things we can do with Terraform is there's multiple ways to provide the environment variable. So we can either do it via command line, like on an ad run, on a per run basis. We can create a variable file, which these variable files we typically like to store in configuration management, such as Git. So it's not a good idea to put them in there. Or we can export it as a specific environment variable, and that's typically what I do. So what we do is we'll type space export tfvar do token. So it's tfvar tf_var_ name of the environment variable you wish to set. We do the equal sign, and then we're going to paste our token here. Now, you may be asking me, why is there a space up here? Little bash trick. If you put a space in front of a command, it doesn't get logged to your history. So if I do echo, this is in my history, I do history, should probably do history less. You can see it's there on the final line. If I do the same thing, and I do this isn't in my history, and I do history pipe tail, not there. Great way of doing environment variables when you're running locally on a machine. Just put a space in front of a bash command. It is executed and not logged to your history, so you don't have to worry about credential leaking. There's your tip for the day. It's actually one of my favorite tips, to be honest. So what I'm going to do real quick is we're going to export tfvar_do_token. Got to put the space there. I'm going to put it over here so you can't see my token. And that's exported. So now what we can do is we can add a data source here. So let's go ahead and go to this, and let's go ahead and get our account info. So let's look at the documentation and see, how do we get account info? So it says data DigitalOcean account example. Okay, so let's go ahead and copy that. And now there's a very specific format that is set up for there is a very specific format that is set up for these, which is, what is the resource type that we're dealing with? Is it a resource? Is it data? Is it a variable? As you can see, Terraform has these. And then the next set is, what actual command do we want to run? We want to do the DigitalOcean account version. So like, this is very specific. This is DigitalOcean account, DigitalOcean droplet, DigitalOcean whatever. This tells us what version, or like what resource we want to act upon. And then this last thing, example, this is our variable. So we can call this whatever we want to call this. This is for us. This is like, Terraform will not care. I mean, obviously use proper variable naming schema, but this is not anything that Terraform will actively look at outside of this file. It just uses it to like reference other things within the file. So use it for yourself. We're going to go ahead and get the data. And what this is going to do is it's just going to get all of our account data. And when we look at it, we have these attributes. That's okay. These attributes here are what will be, these attributes will allow you to basically see what it is. Are you verified? Do you have a status? What's your status message? What's your droplet limit? We're going to use this to do the droplet limit. Guy asks, if you're logged in with the DOCLI, can I skip the token part? I don't think that Terraform knows anything about how DOCLI works, so I think you have to do the token part. Okay, so let's go here. I'm gonna make the text a little bit bigger just for y'all's advantage, and we'll go with like 22. I don't want to make it too large, because if I do, and it's like this, and it's really difficult to read, or it's difficult to fit everything on a screen and like show a lot of it. Also, one of my lights fell over, so these lights, I swear, they are. That's how the day's gonna go. Okay, so now that we have this, what we can do is we can output this data. So there are two different types of variables in Terraform. This is our normal variable, which is our input variable. It works just like a variable you would think of in a programming language. But we have output variables as well. And our output variables are basically print statements. This is how we are able to get data from the Terraform provider and then view it, or we can also export the data as a JSON, and that way we could then run Terraform, export it as a JSON, and then all of the outputs, like what's my server IPs, I can then feed it into my next piece in my automation pipeline. So basically, when we define an output variable, we define its value, and then we basically say data.digitalocean underscore account info droplet limit. Now let's break this down. So value, we're setting it to data. We're telling it that it's a data source. DigitalOcean account, we're saying that go to the DigitalOcean account data source that is named account info, and we want the attribute within it that is droplet limit. So this is all basically one giant lookup for your account info. For Terraform. So it's basically reaching back to this. If we changed this account info right here, it would not come up here and it would probably throw an error. If we change this to say DigitalOcean droplet, it would be, hey, that doesn't exist. We can't do that. So all of this first part is account info, or just the long way. It's basically a variable path. Think of it like a structure, and say it's like dot, dot, dot. It's very nested. And then droplet limit is the attribute. And that's the attribute we want. Then we get that droplet limit. We get that from this documentation. I could change it to any of these attributes right here. If I wanted to know what email address was associated with this account, if I wanted to know my UID, all of that stuff, I could change that to whatever I want. But for now, I just want to see what my droplet limit is. So let's go ahead and run a Terraform plan. Let's run a Did I save the file? Aha, if you don't save your file, things don't work. Another great tip from Mason. Let's try a Terraform plan again. Okay, so it worked, and it tells us that my droplet limit, this is because I work here and I'm special, my droplet limit is 1,000 droplets because I have to do a lot of stuff. The typical account on creation, I think the droplet limit is 10. And then if you want more, you have to request it. But for me, mine is different because, work here, I have to do crazy things. Data sources will give you the answer that you're looking for on plan. So you don't have to run a Terraform apply. Now we could just run Terraform apply. And what it's going to do, it's going to print out the exact same stuff as the plan. And then it's going to ask us, are you sure you want to do this? And we can type yes. There's nothing that happens, but this is the part we were actually looking for, is the outputs are right here. They come out as an actual output. And what I can do is I think it's just double dash JSON. Is it dash JSON? I think it's JSON. Input true, no color, parallelism, state out. Target, is dash JSON? Apparently I don't remember how this works. I feel like I'm being lied to. I've done this before. Like an output thing here? I think I could do it in output. So if I could also do... Aha, there it is. Got it. Okay, so the apply itself may not show you the you can't specify the out as JSON, but at any time. So what happens is we've run this apply. Okay, this apply is now run and saved into this terraform.tf state. This is actually all of the data from my account. And this is what you can use. And the other thing about the Terraform TF state you have to be careful of is it doesn't obfuscate secure things at all. So if you have tokens or anything in there, you got to be really careful. Don't show that off like I just did. Hopefully none of that stuff is secure, but I think it's fine. But it creates that state. And now that we have a state file, we can now access all of that outputs all the time. So you would run Terraform plan apply, then you would do like if you need it to run, I want to feed in my IP addresses of these outputs into another system, I can then do that and go ahead and do a Terraform output, and the Terraform output will then, I can provide it as a JSON. Cool. I'm not seeing any questions in the chat right now, so I'm going to go ahead and move on to the next part. So this is basically just getting data, okay? And I know this is not the most exciting part, but getting all of this stuff set up, getting it tested, this is really going to help you in the next phase of this, which is part 2. So if you're following along in my GitHub repository, I'm now moving into part 2. So now let's actually use this to create something. Like this is Terraform. We need to actually create something. We want to set up things. So we're not going to need this output or this data limit anymore. Let's delete that. But there are a couple data sources that we want to do. Or actually, let's go about it a different way. So let's go ahead and create a droplet. Okay. So if I'm new to Terraform, how do I figure out how to create a droplet? Well, I go to the documentation and I go to the resources and I look for droplet. So there's DigitalOcean droplet right here. And I can literally just copy paste this. I have a question in the chat. What VS Code extension are you using for hints for Terraform? I think it's literally just the Terraform VS Code extension. I think you can just search for it. I love it. It's pretty great. The Terraform linting is pretty simple. So what we do is we have grabbed this, and these are all of the arguments that we have. So these examples that you have here in the documentation is a very minimalistic example. This is not all of the options. These are all of the options. The argument reference is like, what image do you want? Do you want to use what size? What VPC do you want to put it in? Which SSH keys do you want to use? Do you want to specify some user data? Graceful shutdown. And then the attributes are the same thing at the end, which is like, this is the data that we can get back from it once we have created our resource. So now let's go over here into Terraform. So this will allow us to create a basic droplet. We're not going to use 1804. I should probably update those docs. We're going to use 2004. We're just going to call it Web 1. SFO3 is one of our newer data centers, and for some reason, I'm partial to the SFO3 data center, so we're going to do SFO3. But NYC2 is one of the older ones too, I believe. So yeah, SFO3, I like putting it in San Francisco. So this right here, we now have said, instead of data, we now say resource, DigitalOcean droplet, and then we give it our variable name web. And then we follow the parameters. This is basically like calling a function, and it tells us, hey, these are the parameters you have to do. You need to tell me what image you want to use. You need to give it a name so you can identify it. You need to tell us what region. You need to give us a size. And S1 vCPU 1 GB, that's our $5 droplet. So if we come back over here and we do Terraform plan, it will now tell us everything that it's going to do. So first it tells us all of the variables that we have sent to it. So this is a great way of double checking everything to see what you've actually done. So backups, we're not turning on backups. Some of these data points that are going to come in, we won't know until after they're built. Like, how can we know the exact created at time until we've actually created the droplet? This is data that will come from the DigitalOcean API that Terraform will save into the state. And then what you can do is you have disk, you have ID, you have the image that we're going to do, your IPv4 addresses. Is it locked? All of these things you can use for it. And then basically what it's saying is that we did have our output here and we're deleting it. So it has the little red sign, and we're not going to have this output anymore. So now let's run a Terraform apply. And it's asking us, it prints the same thing. And it asks us pretty much, do you want to do it again? We're going to say yes. And now we're going to create a droplet. And if we come over here, we didn't even get to it quick enough. The API is fast. It's already creating the droplet for us. And basically, in the time of creating Terraform droplets or Terraform resources, you basically just sit here and wait. This is the fun part of DevOps, is there's a lot of sitting and waiting on execution. It's like there's that wonderful XKCD that Randall Monroe writes I'm not slacking off. It's my code's compiling and they're like playing. It's the same thing in DevOps. It's like, I'm not slacking off. I'm waiting for Terraform to finish applying. Like, I'm waiting for the config to finish executing. So we have our droplet. It works. Now we do have a slight issue with it. This droplet will work, but it emailed me the password because we didn't set up an SSH key, because the default in droplet is if you don't set a SSH key or a password, then it will generate a strong password for you en route. I don't want that. So let's fix that. I haven't done anything with this droplet yet. I don't want to do that. I want to use it. So let's just go ahead and do a Terraform destroy. We're going to type yes. Kaboom. Droplet, go bye-bye. And this usually doesn't take too long. What we're going to do is we're going to go back and look at our documentation while it's deleting. I have so many tabs. And let's look and see SSH keys. So how does it do SSH keys? It's a list of the SSH key ID or fingerprints to enable them in a list format. Okay. So this is where things get a little bit weird, or they can get weird. but let's do it the smart way. So instead of me going and like getting my SSH ID, which honestly you'd have, like, if I couldn't do that off the top of my head, I'd have to figure out, I'd have to like Google it. Let's use our data sources. We have data sources that show us how to get, I swear if I just had, if I put them in the same tab, I won't have to go back and forth between them. Another tip. If we go here to data sources, let's look for SSH keys. Do we have anything on SSH keys? We do. What's the difference between key and keys? Is it the same thing? Oh, this lets you do. Huh, interesting. Oh, it's some fancy filtering stuff. How cute. I didn't know that was there. So we know the name of my SSH key. So the SSH key is like, the name of it is Mason. Like whenever you create an SSH key in DigitalOcean, you basically will have, where are they? Where'd it go? Why is it not here? Okay, well, let's go get my SSH key then. I thought I added this earlier, but .ssh at .ss /.sshidrsa.pub, my public key. Let's come here and let's add the key. We'll call it Mason. That's my name. Already in use on your account. Intriguing. Okay, something weird happened. Maybe I hadn't refreshed it from earlier. We're good. There's an SSH key named Mason. We're not going to worry about it. So now let's go ahead, and we know it's called Mason. Let's go back to our data source. And how do we get it? And look, there's even an example right here on how to use SSH keys. You use a data source right here to grab the name of it, and then you just put the ID right here. Like we've already thought of this for you, and put it in the documentation. So let's go ahead and say, let's get my SSH key. The name is Mason. And then we're just going to go back to this code right here, and we're going to say, grab that. And now we have our SSH key. We're just going to call this my key, because I don't like the word example. It's not useful. My key. And if I had multiple SSH keys that I wanted to add to this, I would just do different data sources for each of them. And this is basically a list. So this is the same way you would normally interact with stuff in list format. So you would just put a comma here, add the next key. So now if we save this and we go back and we run a Terraform plan, we will basically get everything we need. Now, there's one more thing I want to do. And actually see right here, the SSH keys were updated, and this is the SSH key ID. So we're good. It says that it's going to create it with our SSH key so we can access it. Now, there's one more thing I want to do, is that whenever I'm done creating this, I don't want to have to go back to the DigitalOcean console to know what my IP address is. Like, why would I go to a thing that I don't need it? I'm already here in Terraform. Terraform can tell me this stuff, make Terraform tell it to me. So we're going to type output. We're just going to call it server IP. And then we're basically going to say the value is equal to, and this is the one weird part about it that I really don't like, DigitalOcean droplet.web.ipv4 address. Now, this is a little bit different. So whenever we were getting values from stuff from our data source, see right here how we have to say data, DigitalOcean SSH key, my key ID. But when we're getting value data from a resource, we just give it DigitalOcean droplet web IPv4 address. This is just I wish it said resource here. Yes, it would be more redundant, but it would be consistent. This is my gripe. But whenever you access stuff from a data source, you have to say that it's a data source, and then the resource type. When you're accessing stuff from a resource, you just say the resource type variable. So, what type, resource type, variable versus resource type and variable. This is just a Mason's personal little pet peeve. I would rather it look like this. Yes, it's longer, but it's consistent, and consistency matters. But, it's not that big of a deal. Just, you can make this mistake, and it'll cause you about 5 minutes of pain as you Google it and figure it out. I try to cause people as little pain as possible. Cool. You didn't specify the out parameter to save that's fine. So, same stuff. We have our SSH key. We have our server IP. We're ready to go. Go ahead and do a Terraform apply. And let's type yes. Now, once again, we are stuck here waiting for Terraform to apply. It's not that slow when it's one droplet, but as these Terraform provisioners get larger, as you do more and more stuff with them, it can take a long time. I think the longest, especially because a lot of stuff has to be done serially. Like there's certain things that you have to do serially before you can do anything else. Like we can't create the certificate. I think we can't do like we can't create the SSL certificate for a load balancer until the load balancer is created. So we serialize behind that, and that becomes very common. It will create multiple resources in parallel. So if I said create me 10 droplets, it will create those in parallel. But these can get complex. And it's not even really that complex. It's just things have to be run in order. Like I have to unlock the door before I open the door. If I try to open the door before I unlock the door, it doesn't work. I slam my face into the door. It's the same thing with infrastructure. So we have this. We have our server IP. If I was going to be using this for, say, I want to feed that server IP into Ansible, I could just do, Terraform output JSON, and now, boom, I have this in a JSON type. So we're good to go with that. And that is basically using data sources and resources together. Are there any questions in the chat? So you said, Guy found the answer to my question. This is the DO API token. Alternatively, this can be specified using environment variables. Yes, you have to use the API token. Can you pull images from Docker or other image repos? There is a Docker Terraform provider. So you can do stuff like that if you wanted to. Rod says, breathe. I am breathing. I just speak fast sometimes. It's me. Trust me. I'm good. Okay, what's the next part we're gonna... This is part 2. Let's look into part 3. I'll give everyone a quick second if there's any questions for them to come in. Okay, I think we're gonna get to one. I think we can get through part 3 in this next 20 minutes, and then that'll be it. And I won't get to part 4 of this demo, which is fine. Part 4 will come next week, and then I'll write parts 5, 6, 7, 8, 9, and 10. So, next part. Here we go. Oops, wrong button. So Terraform, is great for standing up, your resources and everything. I don't know why I'm just typing needlessly. But one of the greatest things about it is it's actually really good at, applying the same stuff somewhere else. So if I say I'm running this, in a multi, it could be multi-cloud, but multi-region. So say I'm running this in DigitalOcean SFO2, SFO3, but I also need to run this in let's say Germany in our European data center because of data privacy laws. Like, okay, that's fine. We can easily just change which region we're setting this up into using the same code. But do I really want to change the code, commit it, run it, and then no? It's it's a little bit. Yeah. So we have these things called workspaces that we will talk about. Okay, before we go on, I'm going to answer a couple questions. A resource is something that already exists. No, a resource. Well, when you're inside of the Terraform stuff, resource explains to something that can be created. When you're creating the resource, it can get the data from there. But if you want to be able to get the attribute data from it, like the IP address, it has to have been created first before you can access it. Robin asks, so since you define the SSH key, it disables login over SSH and doesn't email you a password? Correct. So that when you define SSH, you will have your SSH config will have the no password rule. It will not email you a password. Doesn't work anymore. Can you please tell us how we can distinguish the case where editing a resource is causing a destroy and recreate and when it just reconfigures? Yes. Where is that in my notes? That's in this section. So we're going to go over it in this section. Good. Yes, that's a great question because Terraform is like that. So let's actually cover that part first because I want to. Yeah, let's do that. Let's add a couple droplets. So let's just expand on what we currently have. And let's go ahead and do count. So what we can do now is we can create a count. And if we say 3, we will create 3 droplets. Let's change our name here a little bit to be a little bit more, parameterized. So we'll say var.region. I don't have any of that yet. Sorry, I can't do that yet. Web1. So what was asked in the question was about Terraform that destroys stuff. So Terraform, again, this is why this is not a good configuration management tool. When you make a change in this, sometimes Terraform will be able to tweak it, and sometimes Terraform will just flat out destroy it and rebuild it. So let's, if we, I already deleted that server. If I were to change this Ubuntu 2004 to 1804, this is not going to downgrade my server to a lower, like, and run all that command. It's going to destroy the server and spin it up with a new slug. This happens very often. You can very likely cause yourself an accidental outage by not paying attention to the Terraform plan. So always pay attention to the plan and see. It will tell you what is new, what is changed, and what is going to be destroyed. Now, there is something that also that can be kind of bothersome. Terraform has by default runs on a destroy first, then create. So say I have a production instance. I have 3 web servers. They're all Ubuntu, 2004. And I want to upgrade to 2204, and I change that, and it's going to destroy the servers. It will take down the 2004 servers, and then it will stand up the 2204 servers. As you can probably guess, that's going to create an outage because you just deleted your entire web fleet. And now you are waiting on it to come up. So we're going to exactly what Rod just said in the chat. We enter the lifecycle parameter. This is just a special parameter that you would basically you would learn about by reading the documentation. But we're going to do create before destroy. We're going to set this to true. Personally, I get why this is not the default because, this can cost you a lot of money if you leave servers running for a long period of time. So the goal of Terraform is to, not cost you, we don't want you to accidentally incur costs because you spun up 100 droplets and now you're spinning up another 100. That's just double cost. However, that's great from a billing perspective. It's a terrible perspective from a DevOps point of view. So I always put lifecycle create before destroy equals true. I want to ensure that those droplets that I've just spun up, my new fleet, is healthy before I even consider tearing down the old fleet. And in reality, what we used, so this is a real world example of how we used to do this at Verbo. So say we were doing something that was going to create a new droplet resource. We actually, so we ran, say you're running a Kubernetes cluster or a Mesos cluster, we would actually duplicate this resource, spin it up, and then I would slowly delete the other droplets. So what I can do here is I can do count equals 20. So I want 20 droplets. What I would do if I wanted to spin up a 2204 instance inside of a Mesos or Nomad cluster, I would duplicate it, change this to 2204. I would incur the cost of having the doubly sized cluster. And then what I would do is I would do that. And then what would happen is whenever all these nodes joined a cluster, the cluster would rebalance because Kubernetes, Nomad, Mesos, they're all very good for, maintaining a good state. So it would rebalance the cluster, apps that were over here. It would basically 50% across the new and the old. And then literally what we used to do is we would come in here and I would slowly tune this number down. I wouldn't just delete it. We're going from 20, we're going to 15. We're going to delete 10. We're going to run that apply. The certain microservices that are running on those old nodes will be descheduled. They'll be rescheduled, hopefully onto the new cluster, but they will be rescheduled across. And you slowly tune down as you slowly drain and evacuate. You could also, if you have good enough tech and you could just evacuate and drain the old nodes. It depends on your setup, depends on how advanced you have the stuff that you're doing. There's a lot of options here. But this is literally how we used to do it, is we were so worried because I worked for Expedia Group, and we were so worried about losing, accidentally taking down the production cluster and taking down, what is a multi-billion-dollar website. We didn't even mess with this. We took no chances. It would take us a day to do this. We would just sit here all day. I would slowly tune it down. It beats a multi-million-dollar outage. It always does. So, but is that appropriate for your small business? Maybe, maybe not. It's a question that you have to make. And that's why the DevOps practice is so valuable, and why as much as people are we'll never need DevOps again. No, because DevOps people know about this stuff. They have to make this decision. They think about this kind of stuff. Do you want a downsert? Do you want an outage? Because this is how you cause an outage, kind of mindset. So anyway, that was a tangent. I hope it was useful to you, but there's a great saying from one of my ex-coworkers. There are old sysadmins and there are bold sysadmins, but there are no old, bold sysadmins because eventually you learn your lesson and you don't make those kind of mistakes. So, anyway, here we go. This is how you would do it for that. And we're not, so the life cycle before destroy is a good thing. So now let's go ahead and parameterize this. Let's say we've spun up a server, we spun up this stack, and now we want to expand. Our business is expanding. We have more customers. I can't just have this in SFO3. Now I need to expand and I need to spin up a data center somewhere in Europe. It's a better experience for my customers to have local data. So let's go ahead and do that. What we're going to do now is we're going to create variable files. So we're going to create a new file over here. We're going to create sfo3.tfvars. And what we're going to do is now we have a lot of different variables. So let's parameterize our file. So let's go up here to variables. And now what we want to do is we want to be able to say, hey, what region do we want to put this in? Right now, we're just currently saying, hey, put it in SFO3, but we don't want that. Let's parameterize that. So let's say variable region. We're going to say type equals string. So we're going to give it a region string, and that's going to be what tells us where to go. Now, what we don't want to do is if I just did this, and then I come down here and I change region to var.region, it'll work just fine. But say this has been running in production for a while, like this Terraform example, and now we've changed it. It would break CI/CD because we don't have a default anymore. Like now we're asking for a variable that we did not have before. If there's automated tasks running this in the background, they don't know that this has changed. So one of the ways we can solve this problem is by adding a default value. So default equals, we're going to say SFO3. That's where we were running. So right now, I've modified this file. I've refactored this Terraform to where we can specify the region, but current running instances of this will not be affected. It won't change anything. Life goes on as normal. And then we're going to do this similarly with two other things. We're going to do droplet count. This is type equals number, default equal to 1. So we're going to basically say how many droplets do you want? And we're going to say variable droplet size. And then we're going to say type is equal to string. And again, we're going to set the default to our $5 droplet. Standard -1 vCPU -1 GB. And we're good. And now we come down here to our resource. We say count equals var dot, what did I call it? Droplet count. Let me make sure my code is right. Yep. And then for the size, we say var dot droplet size. Now we could do this with a lot more. We could do this with image. I'm only going to show you these three examples today. We could do this with literally everything in here and parameterize it. And the other thing we're going to do is we're going to do a little bit of variable interpolation. Like if I create 10 of these in SFO3, I don't just want them all to be named web1. It's really difficult for me to understand what's going on. So we can use the interpolation syntax of Terraform to basically, we'll do +1 because I like it 1 through 3, not 0 through 2, to name it. So web, and then interpolate, get the region, and then get the index count of the count, basically as a loop. This is server 1, server 2, server 3. And we have that in the resources. We do need to update our server IPs because we have multiple counts now. We can no longer just say, get me the one IP address. There could be more than one. So we do .star. DigitalOcean droplet.web.star.ipv4 address. That will get us all of them. And that is all I have for this part. So this is the working code. But now let's actually set it up to where we can use this and deploy it into multiple places. So let's go to sfo3.tfvars. So in SFO3, we're basically going to say can I explain the count again? Yes, I can explain count again real quick. So droplet count is how many droplets we want to create. The way that this domain-specific language works is it creates basically a loop. This count is a specific variable. You will not see this variable in the documentation on the DigitalOcean provider. This is a Terraform-specific variable of how many of these do we want to allow to be created. So basically, if I set this to 3, I will get 3 droplets. If I set this to 10, I will get 10 droplets. We're defaulting to 1 because that's just the safest and cheapest option. Good question. So when we go to our SFO3.TFRs, we set our region to SFO3. Let's set our droplet count. Let's do 5 droplets in SFO3, and let's change the size. Let's say that I want to do slightly bigger droplets. So let's do 2 vCPU 4 gigabyte droplets. Save. So now what we do is we have the default, but now we have to specify. So if I do a Terraform plan, it's going to actually, let's do a Terraform destroy. Yeah, we don't want any of this old stuff. I guess I didn't do a Terraform destroy earlier. I just didn't break anything. There we go. Okay, so now let's do a Terraform plan. Now, as you can see, look at this. It's creating 1 droplet. I'm not going to use up all your capacity, Harsh. Now that's interesting though, because we set our SFO3 region to do multiple ones. Why is this? Because we didn't specify the Terraform vial. Another option is to use a for each. Yes, this is newer Terraform stuff. Count is kind of like an older way of doing it, but it works. Works great too. So as you can see, we're only creating 1 droplet here. Like normally this would tell us like multiple droplets. Why is that? We didn't specify the Terraform variable file. So right now, if you don't specify these variable files, Terraform doesn't automatically detect them. There is a file that Terraform will automatically detect. It's called .autovars or .terraform.tfvars. There are 2 types of variable files that will automatically be detected, but the one that we created is not. So what we have to do is we have to do a Terraform plan -var file, and then we say sfo3.tfvars. As you can see here now, look, we have 5 servers, and it's telling us each server, this is droplet number 4, droplet 3, 2, 1, and it's going to create multiple droplets. So now, if I have that plan and I want to apply it, go ahead and type yes, and now we're basically creating 5 droplets in San Francisco 3, which, if we go back over here, as you can see, they've all come up. They're all called web-region and then a number, whatever number they are. So now we're spinning them up, and that's going great. Now, while we're waiting on these to spin up, let's go ahead and let's duplicate this file. And let's go ahead and rename this. We'll name this, we'll call this NYC3. Is that the right? Yeah, it's NYC3. And let's go to 3 droplets, and we don't need to, I'm not going to specify droplet size because I'm okay with the VPs, the teeny ones. NYC3. So I have this variable file, and now I can specify which ones are which. Now this is where things are going to get a little bit weird. Hopefully we're done. Here's all of our IP addresses. So now if I run a Terraform plan NYC3, okay, now look what we've done. Look at all of this red. Destroyed. Like we're about to wipe out our cluster on accident. Why is that? Okay. This is actually the thing, is that Terraform, basically there's this state, like, and I think we talked about it before, but there's this state file. This state file is very particular, and it's based on the directory. So right now we can really only have 1 state running. Well, then, like, why is that of any use to us? How do they fit? How do we actually deal with this? Well, the way that we fix this is we use what are known as Terraform workspaces. So if I do a Terraform workspace, do list, every Terraform thing lives inside of a default workspace. So like if you were only applying one thing, you might never notice this. But there are different workspaces that allow us to have multiple state files, and we can switch in between them. Think of these as like different branches or different virtual environments in, say, Python or Node. They're a completely separate execution environment. So we kind of made a boo-boo by doing it in default. So you just have to kind of know that your SFO3 is in default. But what we can do is we can do Terraform workspace new nyc3. And then I'm on a new workspace. If I do a Terraform plan, I didn't do the var file. Got to do the var file. Nothing's getting destroyed. I have all of my stuff here. So I can go ahead and do a Terraform apply to this. And it will create 3 new droplets for me. And here come my NYC3 droplets coming in. So we have that in our workspace, and now we can switch back and forth on them locally. And but you make sure you just make sure you know what workspace you're in. And it just allows you to have multiple workspaces throughout. This allows you to be able to run multiple different environments in a single thing. And this is a good way of doing it. Another way of doing this, I will say, that at least especially if you're doing it in an automated system, and we did this at my last job, is we actually ran every different environment was a different branch in Git. So, US East 1 was in one, US West 2 was in a different branch. And then when we were running this in CI/CD, we would just, clone the specific branch that we wanted, and then we would save the state. I didn't even get into state management today. That will definitely be in part 2. State management is probably one of the most important things about Terraform. And that will definitely be in the part 2. But this little state file, if you lose it, life gets difficult, because then you don't have the ability to delete or update anything anymore, and you can wind up with orphaned resources. Can I give a example where you can create them in 2 regions simultaneously? That is not supported. I don't even think that's supported. Well, no, technically it is. The way that we did it, I don't know why I immediately went to Vim. So what I could do is I could just create another resource here and hard code these into different regions. That's an option. But if you want to do it in one resource block, it's not an option, because region is set. So if I copied this region and hard coded NYC3 and SFO2, I could do that. But that's not an option otherwise. And yes, so now that we have all of our stuff, I'm basically just going to say Terraform destroy. And this is the weird one. You still have to use the var file when you want to destroy. At least I think. Let me check. I'm pretty sure that's what happens. Oh, no, it didn't. You don't have to use the var file for that. You're in the workspace. So I'm going to go ahead and destroy these, and that is all I have. I'm going to drop this GitHub repository. I'm going to as I write more and more stuff on it, it's going to get updated. So I'll think that next month I'll do another Terraform Tech Talk. So be on the lookout for beginning of April. My Tech Talks are usually in the first of the month, but if we don't have a date for that, that could change. But yes, this is workspace select default. Yeah. Do remote backends and DOSpaces support locking? That's a good question. I'm gonna have to look into that. I don't actually know. I don't know off the top of my head if that's the case. My gut instinct is it should, because it does in S3, I believe, and DOSpaces is S3 compatible, but I'm not positive. So I'll have to look. Good question, Guy. I will keep that in mind. I just got done deleting my things. Harsh, if you're still here, I got rid of capacity, so you should be happy with me again. But yes, this is all I have the time for today. I know I went through this fast. There's a lot of stuff in Terraform. It still is definitely one of my favorite sessions, one of my favorite topics to talk about. Next Tech Talk, we'll do another one. Okay, yeah, it does require DynamoDB. I remember that. Yeah, honestly, when we talk about locking and stuff, I'm probably just going to point people to Terraform Cloud. Not going to lie, it's very good. Like managing Terraform state is not fun. It's not a job that anybody wants to do. And if there's a company that does it for you for a small fee, actually, I think they have a very generous free plan. Then I would just go that way. Like stop doing things that are not your primary objective. Like if you're not selling a company that manages Terraform spaces and it only costs you like 20, $30 a month to store Terraform spaces, why would you not do that? If you're doing it for personal projects, I totally get it. But if you're a company and you're a small business and you're trying to do that, please stop reinventing the wheel. Let professionals handle, like, you do your thing and let other people do their thing. Like, they created a whole business on storing Terraform state. Let them do it. Save yourself some time, save yourself some energy. And as someone who used to be a proponent for, I'll just do it all myself. I'm not done. I grew up. Okay. That's what happens when you become a senior engineer. You stop going, how can I do this? And you start asking yourself, I cannot be the first person that has had to solve this problem. Like, someone else has to have solved this problem. So I recommend running TR against DO on GitLab CE pipelines, which supports Terraform state. Ooh, I might look into that then. Maybe not for next time, but I definitely do love GitLab pipelines. Like, those are really cool. Awesome. Well, thank you, everyone. My time is up, and I will see you all within a month or so to talk about more Terraform stuff. Cloud chats this Thursday at same time, 11 Eastern. So if you want to come just see our weekly news show, come hang out with us. That'd be really great. Thank you, everyone, and I will see you next time.